Greetings and welcome to GILFORD'S lectures. So today we are going to be looking at coordinate systems. But before we begin our lecture of today, I'm going to encourage you first of all to subscribe to the channel and turn on your notification bell so that any subsequent uploads you will get notified. Alright, let's go back to our coordinate systems. So what is a coordinate system? A coordinate system simply refers to the arrangement of reference lines or curves used to identify the location of points in space. These lines could be in 2 or in 3 dimensions. That is, the lines that make up a coordinate system could be in 2 or 3 dimensions. It is also important for you to know that the lines that make up a coordinate system are called coordinate axes. Now, let us look at the types of coordinate systems. The very first one is the rectangular coordinate system. The second is a polar coordinate system. The third is a cylindrical coordinate system. And the fourth is the spherical coordinate system. So below, I'm going to show you how to give the location of an arbitrary point P in the various coordinate systems. Now, let us look at the two-dimensional rectangular coordinate system. If you have a point P and you wish to give its rectangular coordinates in 2 dimensions, the very first thing to do is to draw an x and a y axis which meet at the common point O, where O is the origin. This distance is your x coordinate, while this distance is your y coordinate, and therefore the point P has rectangular coordinates xy in 2 dimensions. Let us look at the 3-dimensional rectangular coordinate system. Before we start looking at the 3-dimensional rectangular coordinate system, it is first of all very important for you to know that the 2-dimensional rectangular coordinate system is used for objects that are on a 2-dimensional surface. A very good example is a ball on your floor. That is, the objects that you give their location in 2 dimensions must not be elevated from a surface. They must be on a surface. Another good example is a picture on a wall. With such bodies, you are able to give just the x and y coordinates. But what happens when you raise the object a little distance above the ground? That therefore means that you need to give its x coordinate and its y coordinate from the surface it was raised and the height from the ground. On that note, therefore, we can therefore study the 3-dimensional rectangular coordinate system, which is going to be able to give us the x, the y, and the z coordinate of a body. Okay, so for you to be able to study the 3-dimensional rectangular coordinate system, you need to identify your z-axis, your y-axis, your x-axis, and an origin O where all the coordinate axes meet. Now for a body P, you identify the surface from which that body was raised. Remember that the body P is at an elevation from a surface. Next is to identify the height of the body P or the point P from the surface, and hence that point or that body P has rectangular coordinates x, y, and z in 3 dimensions. Now, let us look at how to give the location of a point in the polar coordinate system. It is very important for you to know that the polar coordinate system is a 2-dimensional coordinate system. Now, if you have a point P and you wish to give its location in polar coordinate, the very first thing to do is to identify your x and y axis which meet at a common point O. The next thing to do is to draw a line from the point O to the point P, and you call that distance r. And the next thing to do is to draw the angle made by the line R with the positive x-axis, and you call the angle theta, and hence the point P we have polar coordinates r, theta. Now let us look at the cylindrical coordinate system. It is important for you to know that the cylindrical coordinate system is actually a three-dimensional coordinate system. For you to be able to give the location of a point, say P, in cylindrical coordinates, the very first thing to do is to be able to draw your cylinder as such. When you are done drawing your cylinder, you insert a z-axis, a y-axis, and an x-axis. Next is to draw the radius of the circle, and you call that radius r, and the angle made by the radius with the positive x-axis. You discover that this radius of the circle at the base corresponds with the radius of the circle above. For a point P, you get its height from the ground and you call it z. R, theta, and z are therefore the cylindrical coordinates of the point P. So now, this is the figure you obtain when you combine the Cartesian and the cylindrical coordinate systems. This is a very important figure, as it is going to help us to be able to solve mechanics and electrostatics questions. Now, let us look at the concept of base or unit vectors. The very first question you will ask yourself is, what is a unit vector? Actually, a unit vector is a vector of unit magnitude and in a particular direction. So unit vectors have magnitude 1 and they are always in a particular direction. Along the z-axis, we have the unit vector Ez. Along the y-axis, we have the unit vector Ey, and along the x-axis, we have the unit vector Ex. And those are the unit vectors for the rectangular coordinate system. So we have 0, Ex, Ey, Ez, where 0 is the origin. So you can simply write Ex, Ey, and Ez. And for the cylindrical coordinate system, along the z-axis we have unit vector Ez. Along the direction of increasing theta, we have unit vector E theta, and along r we have unit vector Er. So we have 0, Er, E theta, Ez for the cylindrical coordinate system. Now let us look at some remarks on the various coordinate systems we have studied. So the very first remark is that the cylindrical coordinate system is an extension of the polar coordinate system. When we are studying the polar coordinate system, we discover that it has coordinates r, theta, and while the cylindrical coordinate system had coordinates r, theta, z. You discover that the only difference between the polar and the cylindrical coordinate system is the z extension for the cylindrical coordinate system. This therefore means that the cylindrical coordinate system is an extension of the polar coordinate system. Secondly, the z scalar is common for both the Cartesian and the cylindrical coordinate system. What does that mean? That for the rectangular coordinate system we have coordinates x, y, and z, and for the cylindrical coordinate we have coordinates r, theta, and z. You see that z is common for both. And the Ez base vector is common also for both the Cartesian and the cylindrical coordinate system. You discover that for the Cartesian coordinate system we have unit or base vectors Ex, Ey, and Ez, and for the cylindrical coordinate system we have unit or base vectors Er, E theta, and Ez. You see that Ez is common for both the Cartesian and the cylindrical coordinate systems. So I hope you loved the video. Thanks very much for watching GILFORD'S lectures, and please do not leave without subscribing. Goodbye and see you in our next lecture.